Hi, good morning, everybody. Welcome to Xamarin University. My name is Mark Smith. I'm responsible for curriculum here at Xamarin University, and today we are excited to have Jeff Prosise from Wintellect with us. Jeff is a co-founder of Wintellect. I've known Jeff for several years and have worked with him on little projects here and there and done some consulting for Wintellect in the past. I think they're a great company, and I'm really excited that Jeff has gotten into Xamarin Forms lately and has been doing quite a bit of stuff with it, doing a lot of stuff in his blogs, and we just thought there might be some great information that he could share with us and with Xamarin University students about porting Windows phone apps over to Xamarin, because that's kind of what he's been doing lately. So, Jeff, how's it going?
It's going great, Mark.
Awesome.
Beautiful spring morning here in Tennessee where I'm at, so can't think of any place I'd rather be than right here doing this lecture. This is awesome.
Sweet. All right, well, let's get started then.
All right, well, thank you. So thanks for tuning in, folks. For those of you that are listening, as Mark said, I've been doing quite a lot of work in Xamarin and Xamarin Forms in recent months, and wanted to share with you a few things that I've learned along the way. This presentation is titled Porting Windows and Windows Phone Apps to Xamarin Forms. I have a lot of stuff I'm going to go through. We have lots of slides, but also lots and lots of code. We're going to spend quite a lot of time in Visual Studio. I'm going to be showing you several sample apps, and the very last slide that I'll put up for you will provide links so that if you care to, you can download all of the sample code that I've shown. The focus of the presentation is what you need to know to port Windows and Windows Phone apps over to Xamarin Forms. I'm kind of assuming that if you're listening in this morning, you're probably a Windows developer or a Windows Phone developer. You probably have some experience with XAML on Microsoft platforms, whether it's WPF, Windows, Silverlight, or what have you. But even if that's not the case, if you're not a Windows developer, have little or no experience with Microsoft XAML, I think you're going to learn quite a lot this morning, because what I've put together is what I hope is a very practical presentation, sort of some lessons learned, all designed to give you a now moving into the world of Xamarin Forms, and you're looking for a way to leverage the knowledge that you may already have regarding Microsoft's XAML platforms. Now, just real quick, so we can get right to the meat of it. As Mark said, my name is Jeff Prosise. I'm one of the co-founders of a company named Wintellect. We've been around for 15 years. We basically do two things. We do custom app development for customers all over the world, and we do developer training for those customers as well. Historically, a lot of the app dev work we've done, in fact, the vast majority of it has been on the Microsoft stack with .NET and Silverlight, WPF, and things like that. But increasingly, we're moving over to other platforms, other tools, and other operating systems. And that's because customers are coming to us today, and they rarely ever say, we'd like you to build a Windows Phone app for us. Usually they want us to build us an app for iOS and or Android, and oh, by the way, it would be cool if it would run on Windows Forms as well. We've done quite a lot of work with HTML5 mobile frameworks like jQuery Mobile and Cordova. But my passion is building native apps. In my mind, a native app is always going to be better than one that's built using something more generic like HTML5, and Xamarin is the way that today at Wintellect we are going cross-platform to build those native apps that run on all of these different platforms. So I want to start with just a quick example here, and by the way, as I said, I do have quite a lot to cover, so I'm going to move fairly quickly here, but I'll try to keep an eye on the questions window, so if you have questions, please post those, and we'll pause from time to time and make sure some of those get answered. So here's the obligatory XAML 101 example in Xamarin Forms. I've declared a content page, which is one of the important page-type visual elements that Xamarin Forms provides to you. And inside that content page, I've declared a stack layout control, which allows me, in this case, to vertically align the other visual elements that I declare. And in this example, those visual elements are two entry controls. Windows Phone developers would think of those as text box controls. They're simple text entry controls, and a button control that a user can click, presumably after they've entered a username and a password, so that we can fire off a call to a service somewhere and authenticate that user, perhaps using OAuth or something like that. Now, on the right side, you see what this application looks like, or what this UI looks like when it's running on Windows Phone, when it's running on Android, and when it's running on iOS. And for those of you who may be just now learning about Xamarin Forms and what it is, here's how I think of Xamarin Forms. For a long time now, Xamarin has provided us with a brilliant way to write cross-platform mobile apps that are native, and to write the logic that drives those apps in C# rather than Objective-C and Java and other languages like that. What's really, really cool to me about Xamarin Forms is that it takes it to the next level. Not only can I use C# to build logic that runs on all these platforms, but now, instead of having to become aware of the various UI idioms of iOS, Windows Phone, and Android, to a large extent, I can define that UI one time in XAML and have it light up on the different platforms, as you see in this example right here. Now, one thing I should note is most of the examples I'm going to show you today regarding XAML will use declarative XAML. A lot of the examples in the documentation, in Petzold's pre-Xamarin Forms preview book and elsewhere, do everything programmatically. Realize there's nothing that you can do declaratively that you can't do. Particularly if you're coming from the world of Microsoft XAML, you're probably more accustomed to dealing with XAML declaratively. So that's where my focus is going to be today also. If you do have experience with Microsoft's various XAML runtimes like WPF and Silverlight, one of the first things you should know is that on Xamarin Forms, yes, we are using XAML. We can exercise it declaratively or programmatically. And while the two languages are syntactically very similar, the visual elements that are available to you in Xamarin Forms tend to be quite a lot different than those in Microsoft XAML. Now, usually there are analogs, but just for educational purposes, I took that simple you saw on the previous slide, and over on the right, I'm showing how the same thing would look if it were recast in Microsoft XAML. And the characters in red highlight the changes. You can see that the structure is basically the same. We still have a page, but I've had to change a lot of the element names. For example, you Microsoft developers are probably used to using stack panels to do horizontal or vertical layouts, text box controls for text entry, or password boxes for password entry. We can do the same thing in Xamarin Forms, but you can see that the element names are quite a lot different. Entry rather than text box, stack layout rather than stack panel. It's interesting, you work with Xamarin Forms for a little while and your mind does the conversion for you. I still sometimes find myself thinking, oh, I need a stack panel right here, and then I have to do that mental conversion to stack layout. But the more you do it, the more you find you think in Xamarin XAML, and this movement back and forth between the two dialects of the language, if you will, becomes easier and more natural. Microsoft XAML or have experience in those runtimes, let's talk very quickly about some of the things that you can expect, some of the differences and some of the similarities. Unfortunately, there are more similarities than differences. Over in Microsoft land, for example, we have various XAML primitives representing shapes, such as rectangles, ellipses, and path. You won't find those in Xamarin XAML, although Xamarin does give you a box view control that on Windows Phone renders out as a rectangle. So you can't declare ellipses and things like that, but you can declare box views. And by the way, one of the things we're going to talk about in this presentation is how to use something called custom renderers to extend Xamarin Forms so that if you did need to declare any ellipse or something in the UI, well, I'll show you how to do that. Over on the left-hand side in the Microsoft XAML column, you see a lot of check marks. Property element syntax syntactically is identical in Xamarin Forms to that same syntax in Microsoft XAML. The styles and resources that you can declare in Microsoft XAML are all supported over in Xamarin XAML as well. Syntactically, they're almost identical. Significantly, the data binding that you're used to in Microsoft land works very, very well over in Xamarin XAML. There are some minor syntactic differences, but in general, you'll find that those are resolved pretty quickly and easily. For example, over on the Microsoft side, you're probably familiar with the data context property in all visual elements. In an MVVM app, you often assign a reference to a view model to that data context property. On the Xamarin side, that same property is called binding context, but conceptually it's the same. Similarly, in Microsoft XAML, you can create custom controls. You can declare dependency properties in those controls. In Xamarin XAML, you don't think about dependency properties, you think about bindable properties. There's even a bindable property class that's analogous to the dependency property class over in Microsoft XAML, allowing you to add properties to controls, define attached properties, and things like that. On the Microsoft side, if you've used items controls like list views and others, you're probably familiar with data templates, a mechanism for defining in XAML what you want each item in an item control to look like when it's rendered out. You'd be glad to know Xamarin Forms supports data templates with the same basic syntax that you're accustomed to over on the Microsoft side. Control templates are interesting. In Microsoft XAML, you can take any control and you can totally and utterly change that control's look by retemplating it. There is no support for control templates per se in Xamarin because of the way it's architected. But you do have the freedom to write something called custom renderers, which allow deep customizations on the controls and the views that Xamarin XAML renders out. I'm going to go into custom renderers in the second half of this presentation and show you some of the really cool things you can do with them. Transforms and animations, something we tend to rely quite a lot on in Microsoft XAML, are supported over on the Xamarin side. The syntax is a little bit different. I'm going to show you an example of that in a moment, but the same basic concepts are supported on both platforms. Do note that in Xamarin Forms, there's currently no declarative support for animations as there is in Microsoft XAML, but there is very rich programmatic support allowing you to access an animation engine and light up that UI in your app using those animations. Custom behaviors, if you've ever used those in Microsoft XAML, you'll be glad to know they're supported in Xamarin Forms. Even custom markup extensions, which, by the way, are not supported in all Microsoft XAML runtimes, are supported in Xamarin XAML. In fact, it generally takes very, very little effort to take a behavior or a custom markup extension or even a value converter, which we often rely on in data binding scenarios, and port those over to Xamarin Forms. In fact, sometimes there are no code changes required at all. So the upshot of all of this is, if you're a Microsoft XAML developer, you have a big head start in Xamarin Forms, but that doesn't mean there's going to be a learning curve. There are differences between the platforms, driven mostly by the fact that Xamarin XAML has to work on a lot of different operating systems. But there are enough similarities that once you start using Xamarin Forms XAML, you'll feel mostly right at home coming over from the Microsoft side. So with that, I'm going to suggest we go into Visual Studio and just build something real quick so you can see what it's like to start a new Xamarin Forms project if you've never done this. So I'm running Visual Studio 2015 CTP6. I have Xamarin iOS and Xamarin Android installed on this desktop machine, as well as the Windows Phone SDK and a few other things. And I'm going to go into Visual Studio, tell it I want to create a new project, and notice I've selected mobile apps on the left because Xamarin is installed here. I see various Xamarin Forms project types over on the right. I'm going to choose Xamarin Forms Portable. As you'll see, this is going to create a solution for me with 4 projects, one for iOS, one for Android, one for Windows Phone, but a fourth that will build into a portable class library that contains all of the shared code and XAML that provides the UI and behavior for the iOS, Android, and Windows Phone projects. So let's just call this thing Hello Xamarin. We'll let Visual Studio do its thing, and if you watch the Solution Explorer window in a moment, you'll see this at the top will, I believe, be the PCL project. Again, this one is the one that contains all of the shared code. Now, if I were to run this thing right now, let's just make the Windows Phone project the startup project. So if I ask Visual Studio to start debugging, We'll see in a moment the Windows Phone emulator come alive with this app. By the way, on the left you see Microsoft's Android emulator, which I use for a lot of my testing. And on the right, the Windows Phone emulator, which is now running the application that Visual Studio just created for us. It's a very simple app with a simple UI containing a label control that says Welcome to Xamarin Forms. Now, let's do this. Let's get out of the debugger and let's make some changes. When you use Visual Studio to create a new Xamarin Forms project, if you look in the file named app.cs, you'll see the application class's constructor. And in it, a property of the application class named main page is being initialized with a reference to a content page element containing the content that you see on that page. In this case, a simple label control. Here, we're not using XAML declaratively. Everything that you see on the screen is being done programmatically, but we're going to change that. So what I'm going to do is right-click the PCL project and ask Visual Studio to add a new XAML page to this project for me. So I'll choose Form XAML page as the type, and I'll type in main page because that's what I want to call this page that's going to be added. When I click add, you'll see mainpage.xaml and a code behind file for it, mainpage.xaml.cs appear. Now, I'll get rid of this label that's declared in there. If we want the user to see the XAML that we insert into mainpage.xaml, we'll need to go back to app.cs and make a quick change. Let's get rid of all of this right here, the code that programmatically builds that UI, and let's set the application's main page property to a new instance of main page, which is that page I just added to the project. Now, if I run this right now, we're going to see a pretty boring screen because I haven't added anything to it. But let's go over to mainpage.xaml and let's declare a button control. Here. Over on the Microsoft side, I use a button's content property to specify what appears on the face of the button. In Xamarin Forms, I use the text property instead. We're going to put click me on the face of that button. And what about alignment and size? Let's do this. I'm going to use a couple of properties of Xamarin Forms named horizontal options. Let's get that right. IntelliSense sometimes working here and sometimes not. I'll say horizontal options equals center. In other words, I want this button centered up in its container, which is the page. And I'll also set its vertical options property to center because I want everything vertically centered as well. Let's clean that up just a little bit. And let's specify a width and a height for that button. In Microsoft XAML, we would use the width and height properties. In Xamarin Forms, we use width request and height request instead. We'll say we would like for that button to be 300 units wide, and let's just pick a value for the height. We'll say 200 units. And if we now launch this in the debugger, we should see a button on that page, hopefully in the center of the page. So waiting for it to start. There's the Windows Phone emulator. And there is that button that you saw. And if I click it, it's firing click events. I'm not processing those events right now, but I could easily do that. In fact, let's go back and do that. The button in Xamarin Forms fires an event named clicked. I will need to manually add the handler. So let's say that we want a method named onClicked executed in the code behind when that button fires a click event. The main page class in mainpage.xaml.cs, we can add that thing in. So we'll do void. The event signature here is exactly what you're probably accustomed to in Microsoft XAML. And all we're going to do here is verify that the button was clicked by popping up a message box. The way we do that in Xamarin Forms is by calling a page method named displayAlert. And we'll just say we want the title of it to say click. And what message do we want in there? We'll just say you clicked the button. And we'll put an OK button inside this alert box that's going to pop up like this. And if we now go back and run this thing again and click the button, before we do that, let's do one more thing. Let's dress that button up a little bit using its background color property. I'll say I want it to have a background color of green. By the way, one of the differences between Microsoft XAML and Xamarin Forms XAML is that in Windows, you use brushes to provide fills and strokes and borders and things like that. There's really no concept of brushes in Xamarin Forms, but most of the controls do have properties with names like background color, foreground color, text color, etc., that allow you to assign colors to these elements. So if I run this thing inside the Windows Phone emulator again, hopefully we'll see a green button, and if I click it, we should see that indeed a clicked event fired, and so there it is. There's the alert box on Windows Phone. By the way, what would this look like on Android? Well, let's make the Android project in this solution the startup project. And let's ask Visual Studio to debug this for us again. I'll go back here and make sure the Android emulator is up in the foreground, and in a moment we should see that exact same UI appear right there. By the way, I am running from my desktop machine. I do my iOS builds on a MacBook Pro that sits about 3 feet away on my desk. I won't be able to show any iOS apps running because I am working from a Windows PC with Visual Studio, but rest assured everything we do here does run and runs very well on iOS as well. Let's go back and ask it to start debugging again there. Looks like it didn't take the first time, and looks like for some reason it is throwing an exception or so. No, it's not. Here's something you should know. I forget to do this sometimes when I create new projects. By default in Visual Studio, when you try to launch in the Android emulator, it will not connect to Logcat. What you need to do before you run the Android version for the first time is go into the project properties, and under Android options, uncheck the box that says use fast deployment. I'll save that, I'll rebuild, and I'll run this in the debugger again, and now we should see it come alive on Android as well. We should see it coming up in a moment here. And there it is in Android. If I click the button, we see that the click event fired, and we see an alert box pop up. So very simple app, but we're seeing the same thing running on 2 different platforms here. Now, let's do just 1 or 2 more quick little things with this, and I'm doing this primarily for you Microsoft programmers out there to highlight some of the differences between Microsoft XAML and Xamarin XAML. What if we wanted to style this button, to give it the background color green through a style rather than through an attribute like this? Could we do that? Absolutely, because styles are supported pretty much the same way in Xamarin XAML that they're supported in Microsoft XAML. So let's do this. We'll say content page. I'm using the property element syntax here, dot resources. I'm going to define a style as a resource, and I'll have to declare a resource dictionary right here, unlike Microsoft XAML. But now I can use the exact same syntax that I'm used to in Microsoft XAML for defining a style. So a style has a setter, which contains a property and assigns a value to a specified property. I can give the style a name, just as I can in Microsoft XAML, or I can simply give it a target type if I want to make that a default style. So let's say we want this style to be applied by default to all buttons. And for good measure, I'm going to get rid of that background color green there, so if the button is colored green, it can only be coming from the style. So we'll declare a setter now. We'll say that the property that we want this style to set is the one named background color, and we'll give it a color as well. So the value will be, and just to make sure that it's a little bit different, let's give it a value of blue. Something else we could do. In Microsoft XAML, you may be accustomed to using transforms to rotate things and scale things and translate visual elements on the screen. I mentioned earlier that those are supported in Xamarin Forms as well, but the syntax is slightly different. If this were a Windows Phone app, for example, and I wanted to rotate that button 45 degrees, I would create or declare a rotate transform or a composite transform object and use the property element syntax to assign it to the button's render transform property. In Xamarin XAML, it's actually simpler. I can use the rotation property like this, and I can say that I want this button to be rotated, let's say, 45 degrees. Now, when I run this thing again, and it looks like I still have the Android project as the active one, so that's where we're going to see it. we'll see that the button hopefully is colored blue this time rather than green, and indeed it has been rotated 45 degrees. And I won't take the time to do the same to run it on the Windows Phone, but I think it's not too hard to believe that it will look and behave exactly the same there. Does it still look like a button even though it's rotated? Of course. I click it, and there we see evidence that the click even fired. So there is your quick and dirty introduction to Xamarin Forms XAML with a slant towards those of you with experience with Microsoft XAML. With those basics out of the way, let's go back to the slides and let's go a level deeper on Xamarin Forms. So hopefully you can see my PowerPoint slides again. In Microsoft XAML, we use layout controls with names such as Canvas, Stack Panel, and Grid to build the UIs that we want, to provide alignment and positioning of the visual elements that make up our UI. There's a similar concept in Xamarin Forms. In fact, Xamarin Forms has a grid control, which is very much like Grid in Microsoft land. It has a stack layout control, which is a lot like Stack Panel. But it also has some others. For example, there's an absolute layout control, which used one way is a lot like Canvas in Microsoft XAML. It gives you very precise control over how visual elements are positioned inside it. But absolute layout in Xamarin Forms does more than Canvas does. It allows you to, if you want, to use units, logical units or normalized units, so that you can position things on the screen regardless of the physical width and height of the screen in pixels. There's also in Xamarin Forms something called a relative layout, which allows you to contain visual elements and to specify their positions rather to other visual elements. Most Microsoft XAML runtimes don't have an analog to that, although Windows 10 does have a new control called relative panel, which is very similar in concept. Content view is one we use quite a lot in Xamarin Forms. If you just want to put something on the page and you want to declare a bunch of visual elements, well, you can declare a content view and declare those elements all day long. Over on the Microsoft side, if you're familiar with Stack Panel, then it'll be easy to understand stack layout in Xamarin Forms. Here I'm using a stack layout to control to stack 4 box views on top of one another. Notice in the first line here, spacing equals 32. Stack layout in Xamarin Forms offers something really cool that Stack Panel does not, and that is a spacing property that allows you to put some space between the elements that it's aligning horizontally or vertically. The grid control in Xamarin Forms is very much analogous to grid in Microsoft XAML. In fact, you can declare a grid, which is sort of like a table in HTML. You can declare row definitions and column definitions. You can use star sizing, auto sizing, all the things that you're accustomed to in Microsoft XAML. And then you can use attach.row and grid.column just as you do in Microsoft XAML to position box views and other elements inside those grid cells. Here again, Xamarin Forms offers something very cool that Microsoft XAML does not. Notice the row spacing and column spacing properties, which allow me to control the space between rows and columns in a Xamarin Forms grid. Those properties don't exist on the Microsoft grid, and once you get used to them, once you're aware that they're there, they tend to come in very, very handy. By the way, something else I haven't shown here, you'll notice that I've defined 2 rows and 2 columns in this grid. I've used star sizing, so I'm basically saying, hey, divide the screen into quarters. In a Xamarin Forms grid, if you're just creating or declaring equally rows of equal height or columns of equal width, you can eliminate the row definitions and column definitions, and it will work exactly the same way. So in fact, I could eliminate over half the XAML you see on the slide, and I would get exactly the same result. Now, in a moment, I'm going to go back to Visual Studio, and I'm going to show you an application that I've ported over from one that was originally a Windows Phone application. But before I do that, I want to make you aware of something that is ultra cool in Xamarin Forms and something that I can guarantee you'll use time and time again. It's called on-platform. It's a mechanism that you can use in XAML or in code, and it allows you to, in shared code, tweak the UI for individual platforms. In practice, you'll find that the exact same UI running on, say, iOS and Windows Phone might look a little bit different. You get slightly different alignments or sizes on the different platforms. With on platform, once you get the basic XAML up and running, you can go back and tweak as needed to make it look exactly the way that it looks to on the different OSs, but do it while doing it all in shared code. So here is an example of how I would use on platform in XAML. In this example, I've declared a simple box view, but I want to give it a different fill color on iOS, Android, and Win Phone. Now remember, this is shared code. It could come right from that main page.xaml file that you saw me add to the shared project. But with on platform, I'm assigning the color property of the box view, the value green in iOS, an RGB value on Android, and the accent color, the current accent color is selected by the user on Windows Phone. I've also used the property element syntax and on platform to give this box a different width on the different platforms. You can use on platform as much or as little as you need to make that UI look exactly the way you want it to look on the different platforms. And by the way, you're not limited to using on platform in XAML. You can use it in code as well. In fact, if let's say that I want to assign values to a pair of variables named CX and CY, but I want to assign slightly different values depending on whether I'm running on iOS, Android, or Win Phone. The first example here shows one way to make that happen. But maybe there's something in shared code you want to do that's a little bit more comprehensive than that. Maybe you have a block of code you want to execute only when this app is running on iOS or only when it's running on Android. In that case, you can use device.onPlatform, as I'm doing here in the second example, providing lambdas so that you can execute one block of code on iOS and another on Android. I didn't do anything for Windows Phone here, but if you wanted to execute some code on Windows Phone, you could just use the WinPhone attribute there and make that happen. So with that, let's go back to Visual Studio and look at a more comprehensive application and see some of the cool things that make it tick. So in Visual Studio, I'm going to open one of the sample link to at the end of this presentation. This one is called Xforms RPN Calculator 2, and while Visual Studio loads it up, I'll say a word or two about why I wrote this. RPN, if you've never heard it before, stands for Reverse Polish Notation. If you, like me, have a background in engineering, you've probably used RPN calculators before. In fact, I can't use an ordinary calculator, one that has an equals button on it. It doesn't feel right to me. So when I'm learning a new platform, one of the first apps that I typically write is a reverse Polish notation calculator. Now, I originally wrote one for Windows Phone 7 a few years ago and published it in the Windows Store. It's still out there. People still download it and use it. But with Xamarin Forms, I thought it'd be very, very cool to bring that same calculator to Android and to iOS as well. So let's take a quick look at what it looks like on the outside. We'll run it first in the Windows Phone emulator, and then we'll see what it looks like on the inside. So in the Windows Phone emulator, we should see it come up here in just a moment. And we see a basic UI consisting of a label control at the top, along with some button controls at the bottom. With an RPN calculator, if I wanted to add 2 and 2, I would tap 2, enter 2 plus, and we see that indeed the results of 2 plus 2 are 4. Now let's stop debugging there and let's go back and run it in Android. So I'll make the Android project the startup project and do start debugging again, and this later it will look pretty much the same, but instead of seeing native what you saw in the Windows Phone emulator, you'll see a UI composed of native button controls in Android and a native text view control in Android up here providing the output. So let's just make sure this works. I'll add 2 and 2 on Android. So I'll do 2, enter 2 plus, and indeed it seems that Android is every bit as smart as Windows Phone because it knows what 2 and 2 are. Now if you run this over on iOS, You'll find that it runs equally well there. It has a default white background, looks slightly different, but functionally is exactly the same. So let's take a look and see what it took to get this app up and running. First off, I added a page to this project after creating it called calculatorpage.xaml, and I did that in exactly the same way you saw me add mainpage.xaml a few moments ago. I then went into app.cs and modified the app constructor so that when the application comes up, what the user sees is an instance of that calculator page class. This is an MVVM app. I have a class that I added named Calculator View Model, all written in C#. It basically provides the functionality of a calculator to the view, and the calculator view model itself relies on a class that I named Calculator, which subsumes the functionality of an RPM calculator. I won't go through all of that code. It's just standard grungy C# stuff, but again, you'll be able to download this and play with it if you want to at the end of the presentation. But let's take a look in calculatorpage.xaml. In this case, the one and only page that makes up the UI of this app. If you look through here, ignoring the on platforms for just a moment, you'll see that the basic UI consists of a grid in which I've declared a bunch of row definitions and a bunch of column definitions. Button controls representing the different buttons on the calculator. I've used grid.row and grid.column just as I would in Microsoft SAML to position those buttons in the grid cells and get the alignment that I want. And in fact, above that, you see the label control. This would be a text view in Android or a text block in Windows Phone that provides the calculator output. One of the things you'll see here is that I am using commanding. If you've used buttons and other controls over on the Windows side, you're probably used to command and command parameter, and using data binding to bind the command property of a button, for example, to a property of the view model that provides an iCommand implementation telling that button what to do when clicked. I'm doing the exact same thing here. I've bound the view model, an instance of calculator view model, to this page, and I'm using data binding here to bind the command and command parameter properties of the button. So there's not much here that would be different if this were Microsoft SAML. Yeah, I'd be using the content property in the button rather than the text property. Other than that, this is pretty much just as it would be in Microsoft XAML. Now, here's something else I want to point out. If you scan through this XAML, you'll see that I'm using on-platform in a lot of places to tweak the UI for the individual platforms. Not just up there, but here. I'm using slightly different row spacings in the grid on iOS, Android, and Windows Phone, and column spacings as well. I did that because I wanted this UI to look approximately the same on each of these platforms, have approximately the same spacing between buttons and things like that. On platform is incredibly important. I dare say you will never build a real-world Xamarin Forms app without using on platform, and in all of my examples you'll see me using it fairly liberally as you see right here. Now let me show you something else here. Let's go back and run this application again. I'll just run it in the Windows Phone emulator. And when the emulator comes up, we should see the same UI we saw before, but I'm going to use the emulator to find out what happens when this app rotates, or when the device rotates. So we'll click this button right here. We'll see the emulator go over on its side, and not only does the display rotate, but you'll notice 2 extra columns of buttons have appeared. Buttons allowing me to perform trigonometric operations like sine, cosine, and tangent, and also to do squares and square roots and things like that. If I rotate the device back to portrait mode, those rows or columns of buttons disappear. Let me show you real quickly how that worked, because this is something that if you're porting applications over from Windows and Windows Phone, you'll probably need to know how to do. Virtually all mobile operating systems today fire events or notifications of various types letting you know when the device is rotated. Windows Phone, they call that event orientation change, for example. Xamarin Forms does not currently fire an event dedicated to orientation changes. It does, however, fire from the page a size changed event when that device rotates, because the size of the page has changed, and there's a virtual method in the page class that you can override if you want, named onSizeAllocated, which is basically called as a result of those size changed events. So here's what I did. In calculatorPage.xaml, not only did I declare those buttons that you always see, even in portrait mode, I declared a bunch of buttons representing those buttons in the two hidden columns. And you'll notice that I've set each of those buttons is visible properties to false. That means that they're not seen by default. But over in calculatorPage.xaml.cs, when the app starts up, soon after it starts up, this virtual method, which I've overridden in my calculator page class, gets called. And when I see that the size of the page has changed, basically when the width and the height have swapped, I call a little helper method named showExtraButtons, which just enumerates all of those buttons in the two left-hand columns and toggles their isVisibility property to true if we're in landscape mode and I want those buttons to be seen, or to false if the device is rotated back to portrait mode. One thing you need to be careful of with these onSizeAllocated overrides is oftentimes, each time the device rotates, onSizeAllocated will be called multiple times, sometimes many times. So I have a little trap built in here. If I see it being called with the same width and height parameters over and over, I basically ignore it every time but the first. By the way, it's perfectly fine if you'd prefer just to here in the page constructor, wire up a handler for size changed events. They do fire typically only once each time the device rotates, so you can accomplish the same thing without having to build in a little bit of extra logic to filter out redundant calls to onSizeAllocated. So again, I'll make this source code available to you so you can download. If you've never seen MVVM before, although you probably have if you're coming from the Microsoft world, you can see what it looks like there. Lots of good stuff there if you're just now making the transition over from Microsoft SAML into Xamarin Forms, just to highlight the differences and the similarities between the two. Let's go back to the slides for just a moment and go a little bit deeper. When you work in XAML, you basically compose UIs from views or controls that particular XAML runtime gives to you. In Xamarin Forms, this is what the views or controls that are available to us currently look like. And a lot of these here are the usual suspects. There's a label control for putting text on the screen, a ListView control for providing scrolling lists of items, complete with data templating to specify what each item should look like. And there are other controls as well. The next example I'm going to show you is a port of an application I originally wrote for Microsoft prior to Windows 8 coming out, called Contoso Cookbook. It was originally a recipe for Windows 8 designed to acquaint developers with the Windows 8 programming model. I later ported it to Windows 8.1, Windows Phone 8.1, etc. We're going to implement the same thing in Xamarin Forms and see how we can make it light up on different OSs. So one of the things I'm going to do in Contoso Cookbook is use a ListView control, which is very similar to the ListView you might be familiar with on the Microsoft side. It is a control that has an items source property, so I can assign to that property a collection of items, and then I can use data templating, as you see here, to specify how I want each item in that collection rendered into XAML. In this example, I'm using a built-in cell type called image cell, which allows me to render each item as an image and a piece of text. And when I do that, when I bind to my recipe data source, which I'll show you in a moment, with this simple XAML, you can see on this slide what it looks like on the three different platforms. Now, image cell is great because it gives you better performance than templates built around custom cells. But the fact is, I might want to take this basic UI and dress it up some. You'll notice on the Windows Phone version, for example, spaghetti with marinara sauce extends beyond the right side of the screen. Well, wouldn't it be nice if we could wrap that? In practice, when you use ListView controls, you'll often find yourself using view cells in your data templates. When you use a view cell, you control exactly what the output is for each item. Basically, anything you can define in XAML can be declared as the contents of a view cell. So here I've taken a little bit more control and I've said, hey, each item that I bind to this ListView control should be rendered out as a view cell. In that view cell should be an image and a label. And since I'm declaring the label explicitly now, I'm free to set its line break mode property to word wrap to get the word wrapping that you see right here. Before we tear into Contoso Cookbook, I also want to mention something else. Not only does Xamarin Forms give you views and cells to work with, it also gives you layout controls, as you've seen, and it gives you a small suite of controls representing different types of pages. When you add that main page.xaml file to your project, Visual Studio adds a content page, which is a generic page that can show any content you want. But Xamarin Forms offers other page types as well. There's a master detail page, which makes providing master detail UIs to users very easy. There's a navigation page, which I'll show you in just a moment, which is great if you're going to build multi-page apps. The user clicks a button or clicks an item in a list view and you want to navigate over to another page to show details of that item. Navigation page is your best friend. There are also pages named tabbed page and carousel page, which are really cool. In fact, we're going to use a tabbed page in Contoso Cookbook, which is going to render out a pivot control on Windows Phone, but similar native controls on iOS and Android. Now here's a quick look at what a tabbed page looks like and how it renders out on different platforms. You can data bind these tabbed pages, by the way, or you can declare items in them or children statically, as I've done here. What I've done is declared a tabbed page, and I've added to its children property 3 content pages containing the content that I want the user to see. If you look at the Windows Phone version of that here, it is rendering out a pivot control. I could put my finger on that screen and slide it left or right and easily navigate between those items, complete with the built-in animations that Windows Phone provides to provide a fluid UI experience. And you can see it renders out slightly differently on Android and iOS, but the point is it's rendering out native controls with the performance of native controls and the UI experience that comes with those native controls as well. In Contoso Cookbook, we're going to see our first multi-page application, which means I'm going to need a navigation page. The basic navigation paradigm for multi-page apps in Xamarin Forms revolves around a navigation page. As you'll see in Contoso Cookbook, I'll modify app's constructor to set its main page not to the page that I want the user to see initially, but to a navigation page wrapping that page. Now, I will inherit through navigation page methods that give me the ability to navigate from one page to another in response to user interactions. And I use the word inherit there loosely. Technically, those navigation methods are there in pages like content page, but they only light up and work when those pages are wrapped in a navigation page. If I do want to navigate the user from one page to another in that navigation or multi-page app, then I can go through the navigation property of the page the user is currently viewing, call push async, which will ultimately call up to that navigation page and navigate me over to the page that I pass to push async. One other thing you're going to see in Contoso Cookbook is something that I didn't discover at first, but once I discovered it, I found a lot of uses for it. Every page in Xamarin Forms has a cool little property named isBusy. If you are placing a call to a web service somewhere, for example, waiting for data to come back, you have no control over how long it's going to take or even if it's going to come back, you may want to let the user know that you're waiting on something to happen. Simply setting a page's isBusy property to true causes Xamarin Forms to display a platform-specific busy indicator. In the case of Windows Phone, it's the 5 little dots chasing each other across the top of the screen. With Android, it's that little circle that you see in the upper right corner. And on iOS, it's a little spinning circle in the upper left corner. Let's take a look at how we use some of this in Contoso Cookbook in porting a more complex application over to Xamarin Forms. So I'm going to open one version of Contoso Cookbook. Again, you'll have access to all of this to download at the end if you want. And let's see what it looks like here. Looks like I currently have Windows Phone as the startup project, which is fine. So I'll run this thing in Windows Phone here. And you're going to see the first page of a 2-page navigation app. On the first page, you see a tabbed page and that has 6 children. Each child contains a ListView control that shows recipes of various types. So here you see Chinese recipes with a nice horizontal scrolling experience courtesy of that Windows Phone ListView control. This is the Windows Phone pivot control that's been rendered out from the tabbed page. If I slide this over, we'll see French recipes. Slide it over further, we'll see German recipes, and so forth and so on. If I find a recipe I like and I want to look at it in detail, I simply tap it. That navigates over to a page that I call Recipe Page, which provides a lot more detail regarding that recipe. I'm showing this content inside a scroll view control so that if it won't fit on the screen, the user sees a nice vertical scrolling experience like that. Now, would it look the same on Android? Well, let's find out. I'll make the Android project the startup project, and we'll run it in Android. Let's get back here. Get the Android emulator visible to us, and we'll see it start here in just a moment. It'll look a little bit different here because there's no pivot control in Android, but you will see a native Android equivalent, and you'll see the same basic experience on Android that you saw on Windows Phone a moment ago. So on Android here, I've got an action bar. I see the different types. If I find one I like, I do love spaghetti with marinara sauce, I'll click it. And in Android, we navigate over to my recipe page, show the details of that recipe. Now, let's take a look inside to see some of the highlights of what it took to put this app together and what was involved in porting it from the original Windows and Windows Phone version. So in this example, I have 2 XAML pages, each of which I added manually to the project. One is called mainpage.xaml. This is the page that the user sees when the app starts up. The other is called recipepage.xaml. This is the one that the user sees when he or she taps something in main page, taps one of those recipes. If you look at main page, there's a lot going in here, but here's what I'm doing. I've manually changed content page to tabbed page so that the main UI for this application is a tabbed page. And I've data templated the tab page. I've said that I want each page to be rendered out as the contents of this data template. In other words, I want each page to be a content page, and in each page, I want there to be here look exactly like they would in Microsoft SAML. I won't walk through the code, but I do have a fairly robust a view model here that is holding the recipe data. I have in code behind instantiated the view model and assigned it to the binding context property of this page so that in the page I can use binding expressions like these to refer to the various properties of the recipe and recipe group objects that are coming from the view model. Inside each list view, I'm using another data template. Notice I'm using that view cell control nicely what gets rendered out for each and every item. And not surprisingly, you see several on platforms in there as well, where I'm tweaking the UI for individual platforms. When I ported this over, by the way, from Windows, probably 95% of the code just ported over and worked. I did have to recast the XAML to make it Xamarin Forms XAML rather than Microsoft XAML, and that took a little bit of work, but it was considerably less effort than it would have been had I been writing this thing from scratch. By the way, let's go over to Recipe Page and take a look at something here. In Recipe Page, I don't have a list view control. The page is a simple content page. And here's that scroll view control I mentioned that's providing the nice vertical scrolling experience if the content won't fit on the screen. So when the user goes to that page, I'm using a vertical stack layout control to show a recipe image at the top, a recipe description as a label, and then I'm using some nested stack layouts to show the recipe ingredients and the directions and things like that. But let me point something else out right here. Notice this binding expression right here. This is the label control on the recipe page that shows the list of ingredients that make up this recipe. The label control has a text property of type string, but if you look at my data source, and it is a JSON data source that I'm parsing here with JSON.NET, you'll see that that ingredients property in my recipe object is a string array. Well, there's no way to bind a string array to a string property type in a label, So I wrote a value converter. Its name is ListConverter. You can see me type is ListConverter, and if you look in the components folder, you'll see its source code. This converter was ported directly over from an equivalent list converter in my Windows project. In fact, I don't think I had to change a single line of code. If you're not familiar with value converters, they sit between data sources and data targets in data binding scenarios, and they're basically notified as data moves back and forth between the two. Specifically, in this case, when I bind the text property of the label to a data source property of type string array, I need to take that string array and convert it into and return a string. So when the convert method is called, indicating that that data is moving from the source to the target, I use string.join to concatenate all the strings together with embedded carriage return line feeds, and now I get a nice list of recipes, ingredients displayed in the UI. So again, a lot of the idioms that you're used to in Microsoft XAML, like list converters, markup extensions, behaviors, they work in Xamarin Forms XAML as well, sometimes require minor modifications, but sometimes do not. One other thing I want to show you here in this app is in app.cs, user could navigate from one page to another in this two-page app. No main page property to the main page in the app. I set it to a navigation page that wraps that main page. That means the user sees this when the app starts up. But it also means that when the user taps one of those items in the list view, because I've wired up an item tap handler to those items, I have the freedom to do this. Through my page, I call navigation.pushAsync and say, navigate me over to a new instance of the recipe page. The recipe page then becomes visible to the user, and it reaches into the same view model and pulls out information regarding the recipe that was tapped to display that to the user. So same song, slightly different verse, not much different than it would be in Microsoft XAML. Now, we're almost out of time, but let me mention this to you real quick, because I think early in the presentation I mentioned something called custom renderers. In Xamarin Forms, custom renderers are your best friend. Xamarin Forms are not for every application. When you want to have highly customized UIs that are not control-based, you may be better off using Xamarin and using OS-specific idioms such as storyboards in iOS to build that UI. But with custom renderers, you can extend Xamarin Forms and make them do a lot more than they will simply do out of a box. Now, very quickly, what is a renderer? As you know, when you declare a Xamarin Forms control like a label, a native version of that control is being rendered out onto individual OSs. On Windows Phone, for example, that label becomes a text block. On iOS, it becomes a UI label. It is renderers that take that label control you declared and create the native equivalent controls on the various platforms. Xamarin Forms has built into it, for example, platform-specific renderer classes named Label Renderer, whose job it is to render out the native controls on the different platforms. The cool thing is you can write renderers of your own, which allows you to build custom controls extending Xamarin Forms, or to modify existing Xamarin Forms controls by seeing and modifying the native controls that they're rendering out. So let me walk you through a quick example of this. I wanted to dress up Contoso Cookbook a bit, specifically its main page, by showing a recipe description under the recipe title, but most of those descriptions are too long to fit in the small amount of space available on that main page. So I wanted to wrap and truncate the text. Believe it or not, the Xamarin Forms label control doesn't give you a way to wrap and truncate text. You can wrap it or you can truncate it, but it doesn't give you a way to do both. So I wrote a custom renderer. It began with a custom class derived from label named wrapped truncated label, which was as simple as what you see right here. Very often when you derive from the built-in control classes in Xamarin Forms, you'll want to add additional properties. perhaps even bindable properties or dependency properties, and you're free to do that. But here, I didn't need additional properties. I just needed a separate control that I could declare when I wanted wrapped truncated text. I then had to figure out how to declare an instance of that wrapped truncated label in places where I wanted wrapped truncated text, and the syntax for doing that here is exactly the same as it is in Microsoft SAML. Namespace on your page. In this example, I called it local, and then use that to prefix the class name when you want to declare instances of that control. The final step was to build custom renderers for this wrapped truncated label. One for iOS, one for Android, one for Windows Phone. They're very different on the three platforms, but here's what you can do. Here's what that custom renderer looks like for iOS. To build a custom renderer for labels, I derive from Xamarin Forms label renderer class. I then use the export renderer attribute you see on the first line here to associate instances of wrapped truncated label with wrapped truncated label renderer. That means when the parser sees a wrapped truncated label, it will emit code that uses a wrapped truncated label renderer to actually create the underlying control. I then override a very important method that I inherited from the label renderer class named onElementChanged. That's called when the element changes or when it's first created. What's really important here is that when I call the base class base.onElementChanged, that gives the renderer that I've derived from the opportunity to create the native control. In this case, for iOS, the UI label, just use a little trick that iOS programmers use all the time. If iOS programmers want wrapped truncated text, they set the UI label's line break mode property to tail truncation, and they set the control's lines property to 0. The techniques for doing this are very different on Android and Windows Phone, but once you write those renderers, indeed you can get wrapped truncated text. Let me show you real quickly. I'm going to go back to Visual Studio and open Contoso Cookbook, which is almost identical to the one you've already seen, except that it does display wrapped truncated text. Let me show you here. We'll bring it up in Windows Phone. You'll see that same tabbed page that is the main UI for the app in just a moment. But under each recipe title, you'll also see wrapped truncated text for the recipe description. Let's make sure that it took it a second time. Sometimes you just have to try twice to get Visual Studio to do the right thing. Hopefully we'll see this come up in just a moment. And there we go. So here's another take on Contoso Cookbook. And this time you see these wrapped truncated labels underneath. Notice the ellipses indicating that not everything could fit into there. Let me show you real quickly what I did to do that. In mainpage.xaml, I modified the data template for the ListView controls to say that I not only wanted a label representing a recipe title displayed, but also a wrapped truncated label, an instance of that control I showed you in the slides, to show the recipe description. Each of the platform-specific projects has a class named wrapped truncated label renderer. Here it is for iOS. Android. Here it is for iOS, very much what you saw in the slide. But if you look at the Android version of it, you'll see that it's slightly different. In Android, if I want to take a text view control rendered out by a label renderer and wrap and truncate the text, I first wait for the control to fire a layout change event so I can measure its size. Then I set the text view control's ellipse size property to this and constrain the number of lines of text the control can display by calling setMaxLines. And what I'm doing here is basically dividing the height of the control by the height of each line of text to figure out how many lines of text I want it to show. Now I could go much deeper into custom renderers. In fact, I have other examples here of custom renderers at work, but they are one of the most important tools in your toolbox for working with Xamarin Forms. And invariably, when you're porting apps over from Windows or Windows Phone, and you want to get the looks and the behaviors that you want on in Xamarin Forms, you will end up writing custom renderers. Just real quickly, because I realize we are out of time, let me show you a project here that you can download. This is something I originally wrote as a universal app for Windows, but now that I've ported it to Xamarin Forms, it runs on Android and iOS as well. It's called Monolife, and when we run it, it looks like Windows Phone is the default, so we'll just start debugging right there. You will see a Xamarin Forms implementation of John Conway's famous Game of Life, one in which you can draw grids of cells and then use Conway's genetic algorithms to evolve them from one generation to the next. I'm dragging the cursor over the grid here. These are just a bunch of box view controls essentially inside a Xamarin grid. If I tap this play button in the toolbar, I begin evolving the cells, and if I click this button, it stops them. I won't go into the source code here. I will make it available for download. I will point out to you something that's very interesting here. In order to make this work, I didn't want to force a user to have to tap each individual cell in this grid to turn it on or off. I wanted to make sure that if the user was simply dragging a finger over the screen, each time the finger entered a cell, I could toggle that cell on or off. Xamarin Forms doesn't give you the ability to do that out of the box, so I built custom renderers to do it for me. Custom renderers that take what has been rendered out on iOS and the events that I need to let me know when a finger is entered to control. So if that's something that's interesting to you, you can download the source code. You can see exactly how it works, see another example of custom renderers at work. And with that, I will conclude by taking you to the final slide. I promised you that I'd make the source code available for download. Here are the OneDrive links where I've posted this code. Each one is a zip file containing a solution. Some of these are fairly large, 10 to 20 megabytes. And there's more here in these examples than I've had time to cover in the lecture. For example, in that Contoso Cookbook app I showed you, all the data that it was using was local, the JSON data, the image data, etc. In real life, you may want to fire off an HTTP request to a server somewhere and pull down the JSON data and the images. So I do have a version of Contoso Cookbook built which fetches all of its data from Azure, and it uses that isBusy property of the page while it's waiting for the call to come back to let the user know that something is happening. So feel free at your convenience to download these samples, play with them yourself, run them on iOS just to satisfy your curiosity that you do, and do feel free to share this this code with colleagues if you want to help get them excited about Xamarin Forms. So Mark, if you're still there, I will conclude now and hand it back over to you. Maybe we have time to answer a few questions.
Absolutely. Thank you so much, Jeff.